The topic of this video is ionic bonding. The essential questions are: how do you find the number of valence electrons of an element? And how do you draw electron dot diagrams? So let's talk first about how ions form, and this should be a little bit of review. Metals lose electrons to form a positively charged ion called a cation, and this process is called oxidation. Okay, and this follows the octet rule. Atoms gain or lose electrons in order to have the same number of electrons as a noble gas. Okay, so now we'll talk about nonmetals, which are just circled on the periodic table. Nonmetals gain electrons to form negatively charged ions called anions, and this process is called reduction. So we talked about how to memorize before on the charges. We're going to talk about valence electrons, which should be a little bit of review. This column has 1, this column has 2, this column has 3, we have 5, 6, 7. Those don't make ions, but they have 8 valence electrons, and we have 4 right in the middle there. Okay, so to draw Lewis dot diagrams for atoms, we're only worried about those valence electrons. So the electrons that play the most important role in determining whether or not a chemical bond will form are those valence electrons. In a Lewis dot diagram, dots are placed around the chemical symbol of an element to illustrate the valence electrons. The chemical symbol represents the nucleus. Okay, so here we have all our chemical symbols in the nucleus. So we have group 1, and it has 1. If we go over to group 18, it's typically going to have 8. Okay, so if it's in the teens, we're just going to take the 1 off, and that's going to be the number. However, helium's different. It only has 2, so we're just going to draw 2. Lithium has 1. Okay, we're back to group 1. Beryllium has 2. Okay, and you can draw them on different sides. On group 13 for boron, it's just going to have 3. We're going to lose that 1. So 1, 2, 3. Carbon is 14, so it has 4. 1, 2, 3, 4. Nitrogen is 15, so it has 5. 1, 2, 3, 4, 5. And when you do this, you can put 1 per side. Okay, I know we put 2 on the side for helium, but for the most part, we're going to put 1 per side, and if you think about drawing a box around it, and then you can add, if you get over 4, you add a second one to each side. So we get to oxygen, which is group 16. You lose the 1, and so we're going to draw 6. 1, 2, 3, 4, 5, 6. Fluorine is group 17, so it has 7. 1, 2, 3, 4, 5, 6, 7. And neon is group 18, so it's going to have 8, which is the number everybody wants. 1, 2, 3, 4, 5, 6, 7, 8. Just like that. Okay, so now we're going to talk about how to put those into formulas, and we can use these to predict. We already kind of know about charges from naming, and we can use to predict what is formed from sodium and chlorine. So we're first going to draw the electron dot diagrams for sodium and for chlorine. So I have sodium, which is 1, and chlorine, which has 7. So it leaves a gap on chlorine's side. So next we're going to use arrows to illustrate the transfer of valence electrons. We're going to go from the not so full to the very full. Okay, so that means sodium only has 1, it's going to lose it. Chlorine has 7, so it wants to gain 1, so it's going to pull that off. So then we have sodium, which is a +1, and chlorine, which is a -1, and we know that fits together. So the resulting chemical formula is NaCl, and that is called sodium chloride. Okay, now let's look and do the same thing for calcium and iodine. So first we're going to draw the Lewis dot diagram. So calcium has 2, and iodine has 7. Okay, so iodine can't fit 2 in there, and calcium doesn't want to give away only 1. It wants to give away 2. So what we have to do is draw another iodine and give calcium, give 1 of their electrons to each iodine. So then we end up with a 2 plus calcium, and a full iodine, which is a -1, and another full iodine, which is a -1. So that gives us CaI2, which is calcium iodide. Okay, we're going to do the same thing for barium and sulfur. First we'll draw the dot diagram. So barium has 2 and sulfur has 6. So 2 plus 6 gives us 8. So barium's going to give both of theirs to 1 sulfur, and they become a 2 plus. Sulfur becomes a 2 minus. Those charges cancel out, and we get BAS, which is barium sulfide.